Well, if you're like me, you just love AI, and it's really an exciting field right now. So I'm excited about doing this presentation today. Um, I will do my standard introduction. So basically, we have a number of meetups coming up, which I'm excited about. And if you know my story, I actually was supposed to go back to work. And then the pandemic hit it. There was another wave of the pandemic. And then my wife says, you got to do something else. And so I started the meetup, and that was about 6 months ago. And we're just starting to get back to work. And since then, we've had about 270 people join, which is really nice. And so we got a bunch coming up here today. Of course, we're doing deep learning using TensorFlow.js, a relatively new product. Just came out on the market, well, not market, but just came out around 2018. So computer speak, it takes about 5 years for these languages to get embedded into mainstream. So we're still new in this process. But what TensorFlow.js does, it allows you to do artificial intelligence in the browser. So we're going to show you how to do that today and give you a lot of free resources. I got Acing the Azure AI 102 exam. This is a new one just put in there. It will be May 5th at 5 p.m., different than our usual times. But I'm actually taking the exam that day, one of my last AI exams to take in this area. And so I'll let you know the secrets of passing that. I've gotten really good at passing these things. I used to study a year. Once a year, I'd take one of these exams, and then it was every 6 months. And now I take about 2 or 3 exams a month. It's just nuts. So I'll give you all the tips and tricks on passing these exams, and actually not just that, learning things as well. And how to use them hands-on. So also we got Acing the AWS Certified Solutions Associate, and I'm going to throw the pro in there as well and give you a study plan for that. That'll be May 14th. Then learning CloudFormation and Terraform. So we'll be comparing CloudFormation and Terraform on June 18th, and then creating an AWS crypto bot. Yes, creating an AWS crypto bot on July 16th. Very excited about that one. And you'll see your artificial intelligence come right back. Okay, so if you want to invest automatically using AI, this is the one you want to come to. And then finally, this will be scheduled. I'm working on scheduling this one. It is Acing the Azure AZ500 security exam. And it just turns out I need to recertify for this exam. So I thought, well, why don't I just create a study plan and let you guys see that? And I'll give you some good information about what's on the exam. So when I schedule that, I'll take it, and then I'll go ahead and do a presentation and say, here's what. And I'm talking about my philosophy of these exams and prepping for them in a moment. So some of the top skills that industry is looking for, of course, is AWS, Azure, and under Google, specifically to Kubernetes and TensorFlow. So this is what we're talking about today. And of course, Terraform. Now, the reason Terraform is cutting so important is that a lot of companies, when they're new to the cloud, they want to just focus on one technology like AWS, Azure, Google. Let's not confuse our people. But as they're doing it, what happens, there's an acquisition. So they end up, and those people don't necessarily use the same cloud provider that you're using. So you end up needing something like Terraform that can program, or create infrastructure across these different providers. Okay, that said, today, we're going to do Mike's standard introduction, and then we're going to have an icebreaker, and then we'll talk about TensorFlow, and then we're going to do a little wrap up and talk. I just want to introduce you to Colab. It's one of the coolest things in the planet. If you're doing artificial intelligence in Python, Colab is a wonderful place to be. All right, that said, we'll go right into the introduction. We are right in the middle of a paradigm shift. Our technical DNA is rapidly changing. Cloud technology is transforming how we do business, how we create value, how people work, and ultimately how people live and how people think. Now, what do I mean by that? Well, it turns out that we don't remember facts anymore. We just remember where to go get them. Okay, with that said, one of the things that are coming down the pike right now is quantum computers, and everyone's getting ready. And this is really what's going to force everyone into the cloud, because not every data center is going to have a quantum computer, right? And not only quantum computers are more efficient and faster about it, they are going to create new experiences. As a matter of fact, hackers are waiting for this. They're grabbing encrypted data, not being able to decrypt it, but just waiting. So when quantum computers come out, they're going to decrypt all that data they have saved. So there you have it. With that said, we are in that paradigm shift. Coding today is like hand stitching of yesterday. See all these women in the room stitching away slowly. And then sewing machines came along, and then you fired everybody and you had 10 sewing machines. The same thing's going to happen with coding. So we pretty much like stitch code together. But we're on pretty much that precipice where coding is going to become automatic, done by machines better than humans. We're just not far away from that. With that said, this actually comes from Jay May's slide on edX, and it's a course I took, and I'm going to talk about that a bit. But he talks about the financial and agricultural revolution, and there was this industrial revolution, and getting closer and closer together. We've entered that scientific digital revolution. We're right on the cusp of that machine learning revolution. You see things are coming tighter together. And then there's what I call enhanced revolution, where people are going to start connecting themselves, right? The creator falls in love with his creation, and he starts connecting himself to the stuff he built. Yeah. That said, when I was a boy, things were fairly simple. We had wind up Mr. Machine, and there were the 3 laws of robotics. And one was a robot may not harm a human through action or interaction. And the next one was similar. A robot cannot will obey humans' orders except if it's to harm a human, right? And then a robot must protect its own existence, except when to harm a human. So robots would never harm humans. And now we entered into the real world of AI, and it's a little more scary. And even Stephen Hawking, before he passed away, warned us about the dangers of AI. And so now we no longer have the Asimov's 3 laws of robotics. We have Microsoft's AI principles of fairness, reliability, privacy, inclusiveness, transparency, and accountability. A little bit different, it's like, oh boy. So we could say that robots do harm people, and they are being used by the military excessively. And the way we do war is actually changing before our eyes. So there you have it. I'm previous military, so I'm watching everything that's going on overseas and going, wow, technology is making a difference on how we do things. Oh, so Elon Musk comes along, and he has created a neuron sewing machine. Anybody know what that's called? If you're familiar with Elon, what neuro sewing machine has he made? What company does he have that does that work? Anybody know?
Is it Neuralink?
It's called Neuralink. Absolutely, Neuralink. And he's created a sewing machine that can sew electrons right next to your neurons and stimulate them. And you can actually operate, put a little, a little infrared in your head there, and just operate your cell phone and never, talk to your cell phone back and forth without actually punching anything in. They have examples of monkeys playing Pong. So there you go. It's here. So with that said, that's the standard introduction. It's like sci-fi, right? Every theme of a sci-fi movie is this: don't mess with Mother Nature. When you do, bad things happen. But it's here, and you're not going to, wish it away. And it's certainly for all of us here studying and learning. It's really not the technology; it's who wields it, right? So we all want to be responsible digital citizens. So there you go. That's a message there. All right, here's the icebreaker today. If you could write a bestseller, what genre would you write? A mystery, a thriller, a romance, historical fiction, or nonfiction? And what would it be about? So this is your opportunity to write a world bestseller. And is it going to be a mystery, a thriller, a romance, a historical, nonfiction? And what would it be about? All right, with that said, there are a number of when you look at certification paths, so you can see in Amazon, they have their machine learning certification. If you look at Azure, they have 3: data engineer, data scientist, and AI engineer. And then if you look at the one I just took, and I don't think this certification that I went through really is that stiff of an industry certification, but I do so many certifications. I was interested in doing this one because it just kind of took care of you. And I think Jason Mays, who did this, did a really good job of it. We're gonna look at it real quick, but I want to say you can do it for free. You don't have to pay for it. I actually ended up paying for this one and getting the actual cert, but you can go through the entire course for free. And I'm going to show you how it's set up real quick. Once again, you can do the course for free without having to, pay for it. You just won't get the cert. And what he does in the course, he typically goes through and does a few videos. I'm gonna click through it real quick here and get forward. And he'll do a video presentation, and then he'll do an explanation of what he talked about in the video presentation. And then you'll have some type of quiz. So if you get a chance to go look at this resource, once again, it is free if you're not going to go for the certification. And I thought it was really good. All right, with that said, when I work on certifications and I teach this stuff for a living, there's 3 things that I really try to do when I approach a certification. Number 1, I try to get a good course, like a video course from Udemy, or I look at the docs. And Udemy, always wait for the deals. So you can go pay $100, $200 for a course, but if you wait, but they constantly run deals almost every week, and their prices drop typically to $10. So always wait for the deals. I don't work for Udemy, but I think when it comes to certifications, they have some really good training. The next thing I really try to do is get some type of lab or hands-on experience. So I don't want to be what I call a paper dragon. I want to make sure that I can actually program this stuff. And there's so much stuff to learn. If you try to learn everything hands-on and try to do all the labs, you'll never make it to the certification. So what I do, I just choose one area to master. Like my last area when I did AZ 400, just passed that exam. That's the DevOps Azure. I concentrated on Terraform. Okay, so do something like that. Concentrate on one area and master it. And then eventually, as you take it more and more, you'll master other areas and you'll blend together. And the final thing I try to do is find a really good quiz bank. And the reason I do that is to find out what to expect. So these exams, you may know the knowledge, but if you don't know how they're asking or what they're asking, then you can still fail. And so make sure you get a real good quiz back. Now, let me warn you, if you go to somewhere like Exam Topics, which might have good question examples, about half of their answers are wrong. So you're really, so if you just go to Exam Topics and you memorize all the answers, you may flunk the exam. So make sure that you find a good quiz bank. Udemy usually has good ones with 5 or 4.7 stars, and people talk about if they're good or not. It helped. But you should be there to memorize questions. Now, a good quiz bank will have a lot of great explanations and links. And what I like doing is when I hit a quiz bank, I'll look at a question I may not be good at. I'll look at the links and I'll go to those links and read as much as I can, learn as much as I can about that area. Another thing that's helpful is the hands-on piece. When I did the AI security when I did the security course for Amazon, I remember the night before I did 3 labs, and it turns out I had 5 questions from those 3 labs. And so I may do something, watch a video or do a question set, and I won't remember it 5 years from now, but I'll remember that hands-on piece for some reason. All right, with that said, let's talk a little bit about AI. There's really 3 areas of AI: artificial intelligence, machine learning, and deep learning. And it's been an evolution, basically. AI, artificial intelligence, around the 50s was all algorithmic, meaning that you just created programming rules and you try to make computers act like humans. So that's artificial intelligence. Whenever you try to make a machine act like a human, that's AI. And then we begin to understand featureization around the 80s. And we started coming up with ways to train computers without programming them. And that was machine learning. And underneath that came neural nets. And that's what we're going to talk about today. That's what TensorFlow is all about. And neural nets is a way to use training to put human intelligence inside a machine. Now, why does it work now? And they're saying this happens around 2010. Well, actually, when I was in college about 20 years ago, I took a course in neural nets. So, but why didn't it work? And why is it working now? Anybody have an idea? Why are neural nets working now and didn't work 20 years ago?
More compute power and
Yeah.
cheaper.
Yeah. It's one reason. You're almost there. You're almost there. Anybody know?
I would say the same thing. Add the computer chips.
Almost there. Almost there. Okay. So one thing is some of the algorithms have gotten better. Okay, that's one thing. But another thing is video games. It turns out that in order to play a video game, you have to have really good graphic cards. Okay. And so what a CPU does, when it has a math operation, it does one math operation at a time. But what a computer game or graphic card does, it does matrices, or it does mini math problems at the same time. And so this ability to, a parallel process math is what these video cards are doing. And then we call them GPUs, graphic processing units. And that's why we're able now today to do artificial intelligence. And you can see here's a tensor processing unit, a bunch of these video cards all stacked up. So that's the reason we can do them now. Thanks to the video game players. All right, so what is TensorFlow? It's an end-to-end platform for machine learning. You can write fast, deep learning code in Python and other accessible languages, which will use that GPU or TPU. And they're able to access many pre-built deep learning models on TensorFlow Hub. We'll take a look at the Hub today. And their whole stack, pre-processing data, model data, deploy model in your application. They are originally designed to be used by Google. So Google created it, and they create specifically for hardware that they were developing, the TPUs. Right? And so there's lots of references. Here's one is TensorFlow Hub. And if you go there and take a look at that, you can just get started right away with guides and tutorials, and models are just all there to start you programming. And you may have an idea and it may be there, and they're there to help you get going and running. We're going to actually give you more resources today to get started. And why do you use TensorFlow? Well, it's easy for model building. It's robust machine learning production anywhere, and it's powerful You can do powerful experimentation for research. These are all good things. These slides come from a resource on Google. And if you go here to GitHub, TensorFlow Deep Learning, they have an entire GitHub devoted to learning TensorFlow in Python. Now we're gonna look at TensorFlow.js today, but they even have an entire book that you can go to and access with videos and tutorials. So I mean, there's just lots of resources out there to learn AI. So it's in the slide deck. If you haven't learned that, download the slide deck, please do. With that said, what is TensorFlow? TensorFlow is the JavaScript specific version of TensorFlow, the one that you use Python for, right? That emerged in 2018 due to the demand for a production quality JS library aligned with original implementation. So what happened was, before 2008, Flash was really big, and some of you guys may know about Flash or not. It was an Adobe product. Then 2008, Google created its V8 engine, which made JavaScript at C speeds on the web. And then in 2010, they created something called Node.js, which was a server language written in JavaScript. So now, and we're going to use Node.js today. And then TensorFlow came out, and then 2018, they created TensorFlow with JavaScript. So now you can run AI in the browser, and we're going to give you some examples of that today. Matter of fact, we're going to give you an example of that right now called Teachable Machine. All right, Teachable Machine. We're actually going to do an AI example right now. And what I want to do, let me see, do I have a, I might be able to chat this out to you guys. Here's a link for Teachable Machine, if you want that. And I'm going to go there right now. And Teachable Machine is an example of transfer learning. And what that means is they already have a model they've created. And then you can adapt that model for whatever you want to use it for. And so all you have to do is when you adapt the model, you're kind of training the front end and the back end, okay? And so let's go ahead and do an example. And in order for this to work, I need to turn off my video because it's going to use my video camera. Let's see here. Okay, so you can still see the screen. Is that right, guys?
Yes.
Okay, excellent. And I'm going to do an image process here. I'm going to use a standard image, and I have two things I'm going to train. The first thing I'm going to call, let's do a pin. I'm going to do a pin. And I'm going to do a cup. Remember, all this is happening in the browser. So what I'm going to do is I'm going to turn on my video camera. And I'm going to train this thing to recognize a pin. Okay. And so I'm going to do 100 images. Now, when you do the main body without transfer, if this was didn't have transfer learning working, then I would have to do like thousands of images. But I'm just going to hold down, do 100 images. There's a pin. Okay. Okay, I should see a pin. I did just need about 100 images. Okay, now, the next thing I'm gonna do, the next one I'm gonna train on a coffee cup. Okay, here's my coffee cup. Hold on, let's do about 100 images. There's a coffee cup. Okay. I did a little bit more than 100 images, but okay. And I'm gonna train my model. So it's actually physically training the model right now in my browser. And so in my browser, there's something called WebGL. And WebGL is the 3D processor uses my GPU for processing images. Now, the difference between a CPU and a GPU, however, is that the CPU will clean up after itself JavaScript, but the GPU does not. So one thing you'll need to do is when you program in the browser, you have to remember using commands like TF, that's TensorFlow tidy, which will clean up your do garbage collection for you. So you have to actually program in your garbage collection for GPU work. Okay. With that said, it has now trained the image, and I'm going to see if I put a pin in front. Does it recognize the pin? It says it's a pin. What about a cup? Does it recognize the cup? See at the bottom? All right, see it says a cup, pin. See, it's recognizing what I'm holding up. Cup, pin, cup, pin. So you actually can export this model, right? And you can put it on a machine that will actually recognize a cup or a pen. So if someone walks along, hey, he's holding a cup or he's holding a pen. So that's a nice example of using transfer learning. Any questions on that, guys?
So can you map the GPU to a different server in the network, what you are using the browser, or it has to be on the same computer?
I can export this model and use it anywhere. Okay, and so that's a really good question, because when you're training models, you're intensively using those GPUs. But once the models are just trained, then you can use a lower level processor to run it. You have to use a high level processors to. Usually you use a higher level processors when you're training, and once a model is trained, it's just an API. You can send it in. You can use it anywhere. Good question. All right, and we'll show you how to export a model today. We're going to use a program called Glitch, and we're going to export from Glitch today. Okay. Get off of that. That was the first demo. All right. With that said, we'll continue with this presentation. TensorFlow.js pre-made models. There's lots of them out there. So let's go ahead and take a look at those. So you can actually use these models, retrain them for whatever you want to use them for. And we're going to look at here's a few: image classification, object classification, body segmentation, pose detection. Actually, pose detection is very interesting because during the pandemic, I actually got my certification in Zumba, and they had a pose detection system on there. So you had to dance certain moves, and it would actually show you where it would, look at your body and tell you if you're making the dance move correct or not. So there's lots of applications for this. I'm gonna show you the hand pose. Let's run that one real quick. So if I click on this, it will take me to the Google site where you just all the codes there. Just use it as you want. And then there's a demo here. Let me see if I can find the demo right here, showing you where it's gonna model your hand and how it's gonna put the points on it. And then where is the demo? Here's the demo right here. So if I click that, give it a moment. Okay, and then it's going to take it a few moments to get live in my browser. So what it's doing, it's downloading the TensorFlow application. I'm going to show that package, and I'm going to show that package to you a little bit later in the presentation. Okay, it'll come up in a moment. The FPS, that's frames per second. If you were a Flash program back in the old days, you were always trying to get 30 frames per second. So here I am. So if I hold my hand up, you can see it's modeling to my hand. See that? And so when I close it, see, isn't that amazing? It's automatically modeled to my hands. See that? All right, so it's using transfer learning to do that. Then I could take this same program and I could, use transfer learning and use it for something else. All right. Any questions about that, guys? Can you see that? So if I wanted to build a machine that could shake your hand, I could actually do that, right? Using something like this. All right, with that said, that was the next demo. All right, let's get rid of that. And that's the pre-trained models. Okay, move over there. With that said, that demo right there. And so another site, I'm really psyched up about this one. And this is the TensorFlow API. So I'm going to put this link in the browser and the chat, and feel free to go there. But I'm going to tell you why I'm so excited about this particular site. Getting up here. Let me find the chat here. Give me a moment. Okay, being dumb. Okay, what's so cool about these APIs, which makes them different than any APIs I've ever looked at in my entire life, is that, go there. These are all the commands that TensorFlow will do for you, okay? But as you scroll down, and we'll go specifically to, let's do add, for example, TF add. As you go down specifically, you'll see in these particular examples, there's edit, and then there's run, which is, wow, what does that mean? That means I can actually go in there and I can actually edit and run these. So if I want to add these two tensors together, I hit run. I just added them together. So if I come along here and I want to edit now, say I don't want to add 1 to 10, maybe I want to add 100 to 10. So I can come along here and put 100 and run it again, and I get 110. And so lots of times you spend time just looking at API documents or API and say, what does that really do? What does that mean? What you can do is go through any of these commands where they have examples and edit and run the code and figure out what it does. I mean, this is just really, cool stuff. So it's really like an interactive site. It's their whole documentation on how things work, but it's actually edit and command on everything else. So you can play around and actually learn how to use these different commands themselves by actually playing around with them. So experiment, play around, and that's how you learn best. So really excited to see stuff like that come out. That's pretty amazing. I come from the old days. I've been doing this for over 30 years, and in the old days, it was really hard to figure out how things work. You just had to play with them. Here, they just give you playgrounds automatically right in the browser. All right, with that said. Okay, so now we're going to talk about what a tensor is. Are you guys ready? A tensor is a data structure. All right, and just keep that in mind. I'm going to explain to you what it is. The first tensor is a tensor of rank 0. All right. And a rank 0 is what's called a scalar. All right, and that's just a number. All right, so that's a rank 0 tensor. And here's the code how to create it. We won't get too much into that. Okay, that's tensor 1. Tensor 2, what you call a tensor level, that's tensor level, that's a 0. The tensor level 1, okay, is a vector. All right, it is a one-dimensional tensor. It's of rank 1, but hold on now. That's not really what it is. It's an array. Okay, and this is where people get, and we are used to array of numbers. Someone put a 3, right, and a 2. So that could be a vector in 2-dimensional space. But if I put a number in there, that could be a vector in 3-dimensional space. If I put another number in that array, that could be a vector in 4-dimensional space. So just keep this in mind. A tensor is not dimensions. It's an array. Okay, it's a data structure. Keep that in mind. So what would be a tensor of rank 2? Anybody got an idea?
An array of an array.
An array of an array, right? Array of arrays, absolutely. And you can see that this is right. This is vector. That's rank 1. Next one would be the right. It's a matrix or it's an array of arrays. Look at that. This is your rank 2 tensor, and it's just an array, right, of arrays. So if you're used to doing multidimensional programming in in JavaScript, that's what you do when you want to go to the 2 dimensions. In a sense, an array of arrays, you just start stacking them together. And that's what we call a matrix. All right. So what do you think a tensor of rank 3 would be?
Array of array.
Absolutely. Absolutely. You nailed it. So what you're doing basically is now stacking up these matrices in a cube, right? And so we'll take a look at the next one, and so this gets really simple. Wow, I didn't know it was that easy to understand what a tensor was. It's just an array of arrays. That's exactly what it is. And it's like matrices stacked up into a cube. Now, what would be an example? What data structure would this be? Anybody have an idea how would I use this to program something? What data structure might this be? I'm gonna call this R. I'm gonna call this G. I'm gonna call this B. Anybody know what I'm getting at?
Computer vision or red, blue, green.
Red, blue, green. Absolutely. If you're looking at an image, right? And images are composed of actually 3 images. They're composed of a red image, a green image, and a blue image. You know that? And so so basically you could use this 3D tensor to represent an image. All right, good. Now, if I was to go to the next level, the 4 rank 4 tensor, what do you think I could be represented by a tensor of rank 4? So now I'm stacking up these cubes. What can be represented as a tensor of rank 4? So if a rank 3 is one image, a video, right? So rank 3 is one image. So I start stacking up a bunch of rank 3s. I've got a video. Absolutely. And then you could just say the blame. So that's array of an array of array of arrays. So rank 5 would be array of array of array of array of array of arrays. So that's all there is to it.
Hologram?
Huh? Yeah, there you go. Hologram. So guys, there you go. It's like all the tensor is a data structure and it's an array. And so there you go. It's really easy to understand. Now, with that said, one of the cool things about Jason May's course was he used glitch to program. So if you're ever teaching this stuff like I do, you're always looking for a way to make it easy, and setting up an environment is tough. And so he used glitch.com. And I'm gonna go ahead and put this in your browser. Let me see if I can actually get this to key and I can go to it. I'm gonna put this link into your browser. And glitch is free, okay, for 1,000 hours a month. And it actually allows you to program TensorFlow right in the browser without any setup. It's already got everything set up for you. So let me go ahead and send this to you, which I thought was just totally amazing. Okay. And if you go to glitch, like I just did, you can see I have some projects set up. And we're actually going to take a look at something. He actually created a boilerplate for TensorFlow. And it's basically it's the hello world for TensorFlow, and it's just the absolute minimal needed to start a TensorFlow program. So I'm actually going to put this link in your browser, and you can take a look at the glitch boilerplate, and we're going to talk about what's in it. All right. So if you've done a bit of programming in on the web, you'll be very familiar with these terms. If not, I'll explain them to you. Okay. But here's this hello world. And the first thing you want to do with this hello world is do what's called a remix. So you scroll down, it says remix from your own. So it's pulling it from your repository and putting it in your repository. So it'll be in your dashboard when you start programming and it's yours, okay? So it's going ahead and doing the remix, and it's going to give you the files to start working with. Now at the bottom of, it's still making them, 1 second. Oh, cool. And now you can see it's running because you can see the CSS is kicking in. At the bottom, you see status, logs, terminal, and tools. And you'll be using some of those tools if you want to export whatever you did. And we'll learn how to do this in the browser. No, excuse me, on your local machine. I'm going to show you how to take it from here, a model that you create, and put it and get it running on your local machine. Okay. And then you have a little terminal here that we'll need that for your refresh, and you'll see us use that in a moment. So let's see what was downloaded from glitch as the boilerplate. You have these files over here, and what you see is index.html, JavaScript piece, and a style piece. So the index pretty much is just an index file. And it's, so HTML is like the bones of your body, right? JavaScript is like the muscles of your body. And CSS is like the skin of your body. It's what makes you pretty. And so if you look, what's interesting here in the HTML is this package import. And this actually here is the TensorFlow. And it's been minimized, so we're bringing that down. So if you've never seen minimized script, let me go ahead and grab this and show it to you real quick. So I'm going to go ahead and bring up my browser and stick this in the browser so you can see the minimized script. This is what's being downloaded into the browser, okay, and being run to make TensorFlow work. Give it a moment. Typically, it doesn't take that long, but there you go. And what minimization does, it actually moves all the spaces. It just crams everything together. See that? So that's the actual code all crammed together. And that's what's being downloaded. So your TensorFlow will work, your artificial intelligence will work in the browser. Okay. Just shows you how fast things are. When I first started, it was be unbelievable that we could do something like this. Now it's nothing. With that said, that's pretty much what there is. And then you have the script tab for any JavaScript that you write. We're going to write some JavaScript today. And then the CSS, we'll leave that alone. But once you get things running, what you want to do is you want to do a right click and do an inspect over here. And you can inspect what's happening using your Google console. And we'll be doing that a bit today, okay? With that said, I'll X out of that. That was the demo for that. We're coming back to this in 1 moment, all right? Cool. All right, so we discussed that, and we're gonna do a remix here in a moment. So are there any questions so far before we go into the next demo? Any comments? All right, so what we're going to do here is that we are going to create a bunch of tensors. All right, and then And so what's going to happen in this code? And you guys can follow along if you'd like. The first thing you want to do is get glitch, and then you want to download the boilerplate, which we did, and you want to do the remix, and then you're going to add the script below. And what the script is going to do, it's all JavaScript. It's going to create a function called create tensors. Then for 1,000 tensors, it's going to go through a for loop. So it's going to create a constant, which we're going to call a tensor 1, 2, 3. That's a 1D tensor. What is that? That's a vector. And it's going to create a scalar. That's a tensor of that's a 0 tensor, and that's going to be tensor B. And then we're going to multiply tensor A times tensor B. All right. And so if it's 1, 2, 3, you multiply by the variable 3, then it would be 3, 6, 9. So we're going to create 1,000 of those. All right. But there's going to be 3 tensors. So it'll be 3,000 tensors created. The A tensor, which is the 1D tensor, the 1 rank tensor, the B tensor, which is the 0 rank tensor, and the multiplication, which is the 1D tensor. Okay. And then what we're going to do, we're going to run the create tensors, and then we're going to attach it to an element, and we're going to print out the number of tensors that were created using the tf.memory.num tensors. What the tf memory does, it gives you everything about the tensor, and you go one dot notation down, and you're going to get the number of tensors that were created. Okay, we're going to create and run this code. So all you have to do, if you downloaded the slide, just copy this code. All right, and I'm going to copy this code and paste it in my JS and run it. Okay, let me go ahead and grab this. And I can put this in the chat as well if you want it. When you're copying code like this, you always have to be careful of special characters as well. Hopefully I didn't pick up any. And then what I'm going to do, I'm going to go back to my glitch. Let me bring that up. And what I'm going to do is I'm just going to copy all this into the JS script. All right. And give it a moment. And it does this crazy thing. I don't know why. Let me get rid of that. There. Okay. Let me get out of that. I don't know why it always does that. But anyway, okay. It wants me to click back on this screen right here. There you go. So you can see it's been copied in. Here's my function tensor. Here I'm going to create all these different tensors, and here it's going to print it out. And it's already done it. Look at that. It says the number of tensors created was 3,000. So let's actually go to the console, hit inspect, and you can actually go ahead and see those specific tensors. They're down here. And let's go scroll all the way up. And we can see that the first tensor was 0, 0, 0. And so I multiplied that first tensor times 0. The next tensor, I multiplied the next scalar in the for loop was 1. So 1 times, 1, 2, 3 is 1, 2, 3. The next time I multiplied times 2, so that's 2, 4, 6. The next one I multiplied by 3, so that's 3, 6, 9, then 4, 8, 12, at 5, 10, 15. So it's generating all these tensors. The problem that I'm having here, though, is I've generated these tensors, and they're still there. And so if you start working from your GPU and you start generating tensors and they're still there, you get something what's called a memory leak. Does anyone know what a memory leak is?
You will lose this memory without a method to pull it back or use it again.
Absolutely. Your memory just keeps increasing, 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 increasing. Your program gets what? Slower and slower and slower. So, and then you have to release that memory. And so you get a memory leak here. And so you want to release that memory. And so what I'm going to do to release that memory, let me get rid of the console here, is I am going to use something called tidy. And what tidy does is actually deletes all your tensors. So you're going to see all the tensors are still going to be created, but they are going to be deleted once they're created using tidy. Now you can see all of these red dots right here. So go to your terminal, all right, and type in the word refresh. Okay, so I put some new code in there. It realizes I put some new code in there, and it actually wants me to, let me try this again. All right. Can't see my terminal for some reason. Try this again. Well, let me just go full terminal. What's going on with my terminal? There you go. And it wants me to hit a refresh. So let me refresh. Okay, and that terminal is a glitch terminal. and it's going to do refresh for me. And when the refresh happens, you'll see these red dots will go away. And you can see already that's happened, and you can see, and the dots are still there for some reason, but what you see is that it's showing tensor 0. You see that? There's no tensors because what happened, it got ran. Now let's do the inspect. So it still created all the tensors, but once it created the tensors, it did what? It deleted them. Okay. So that's what you want to do is when you write these functions, when the functions are done and you processed all the information, you want to do your garbage cleanup with something like tidy. Okay. All right, cool. All right, that said, that's the next demo that we had in this example. And so let me go ahead and clean this up. And let me see where we're at as far as time is concerned. And we're still doing good. And that's where we're at right now. Are there any questions so far? I'll bring you guys up.
So is this standard pretty much for every time you're doing something?
Whenever you create a function in TensorFlow, TS, you want to clean up that function. Yeah.
Okay.
I've seen a lot of this happen in JavaScript. People get these memory leaks because they haven't executed the functions correctly, and the memory just keeps going up, and the program gets slower and slower and slower. You know, so especially in development, you see that happen a lot. All right, so we are kind of at a 5-minute break spot. We're going to take a 5-minute break here, and then we're going to come back and we're going to start getting into how these neural net works. And we're going to learn a little bit about generative neural networks. And then I'm going to show you something that's not shown to you in May's course, and that's how to run the code that we write here on your local machine. So what we're going to do is we're going to set up a server on your local machine using Node.js to serve out this content so you can get this actually working on your local. All right. So we'll do that when we get back. We're going to have a 5-minute break, and I'll see you guys in about 5 minutes. So let me get my timer up here. Okay, we are back, and we're on the the downward slide of the rest of this presentation, and we're going to get into neural nets and kind of how they work, and then we're going to actually see some examples. So are there any questions so far? Let me ask you, was everyone able to download the slides? Anyone get an opportunity to do that?
Yes.
Excellent. Excellent. Cool, cool. All right. Let's see if there's anyone that had difficulty downloading the slides. So has anyone done any AI work in the browser at this point?
No,
Is this all new stuff?
it's all new.
Yeah, okay, excellent. And
For me.
yeah, it takes about, like I said, it takes about 5 years for a programming language to get into the mainstream. And so this was about 2018. And so we're looking at least another 3 years before you start seeing a lot more of this. So, but it really does, it's not that different than Python, and there's ways to convert Python into the TensorFlow.js. If you have some models, not all of them will convert, but many will. So with that said, let's talk about neural net models a little bit. Neural net models are very interesting, but what you need to understand is that for you to do machine learning of any type, you got to translate it into math, into numbers, okay? Machines don't understand words, they don't understand images, they understand numbers. So if you have an image, if you have words, whatever, you have to turn it into numbers. And those numbers are a tensor. And what comes out of the machine is not words, is not images, it's numbers. And so that's a tensor. So tensors go in and tensors come out. And they go into an entry layer, and then you can have hidden layers, and we'll show you how to create a neural net today, really easy using TensorFlow Playground, and they come out to an exit layer. All right. And so with that said, we'll show you another slide. And so just like I just said, you see that you have, make the screen just a little bit larger. You see that you have what's called your when it comes to a neural net, you see what you call your input layer, and then you have your hidden layers, and you can have many of them, and you have your output layer, okay? And so what a neuron is, a single neuron is consisting of a bunch of inputs. and those inputs are weighted. So like your brain might see one feature or aspect more important to another, then the weight would increase. The same thing is with these neural nets, that you have many inputs, but some may be more important than the other. For example, if I'm selling a house, that price of that house, well, the size of the house might be more important than actually, let me see, how many doors were in it, for example, or may be more important than, you know, if it, of, you know, how much acreage was on it, or maybe not. So acreage, and it just depends. So they have lots of examples that you can go through where certain features are important or not, and what's most important gets more highly weighted. And then it'll go into a bias of some type, and then into an activation function. And a lot of work has happened with activation functions. And I mentioned how algorithms, some of the work that's been done with activation functions really has made neural net more viable today, in addition to the graphics card that we mentioned. All right, with that said, one more thing is you can see an example here of a neural net, and what it's doing is inputting this number. And so this number actually lays on a pixel grid of 28 by 28. So what it does, it inputs every pixel as an input to the into the neural net. So you got 28 by 28 multiplies together, you have 784 inputs, or that's 784 pixels. And they'll go into your hidden layers, and then you'll have an output. And right here, this is using one-hot encoding. And what one-hot encoding do is interpreting the output as a 1 and all these zeros. And so if you get a 1 here, it's a 1. If you get a 1 here, it's a 5, or if you get a 1 here, it's a 9. So it's relatively simple to understand one-hot encoding, but you'll hear those words whenever you take any of these cloud exams. All those concepts are important. All right, but really from my perspective, a neural net really is a generalized logic gate. So if you're familiar with logic gates and ORs, then you'll understand what I'm talking about, but these are generalized in the sense that these weights determine it's not just a 0 or 1 going in, it could be a fraction of a number going in. So, and there's still a lot of work to be done with neural nets. What you're really doing is what you're really doing in neural nets, you're creating a segmentation in multidimensional hyperspace. I know I'm a nuclear physicist, so I think in that area, for some of you guys, this idea of hyperspaces may be really new. And we're going to show you a two-dimensional example of a tensor, and that should help you understand a little bit. So let's go ahead and do that right now, so I don't lose you too quickly. And there's a nice example of this, and it's TensorFlow.org. So I'm going to go ahead and send this link out to you guys, and you should go there right now and play around with this. So let me go and get this link up, and I'll put this in the chat. 1 second. You guys can go here. Can you guys still see my screen?
Yes.
Okay, so you go ahead and take that link up in the chat, and then you go ahead and go to this link right here, and you're actually in a real neural net. And so this is a playground just to get you an idea of how they work. And so what I have here is I have these two, in a sense, cluster pieces of data that I want to actually separate in 2 dimensions. So I've got here an input layer of X and Y, and I have 4 neurons, and I have 2 output neurons. And these are my hidden layers here in the middle. So I just run this, and it actually runs real quickly, and it can actually separate them fairly rapidly. So that's pretty cool. So I can stop that, and I can come here and I can hit the next one. Now there's 4 areas here. So let me go ahead and run the neural net again. It's trying to separate them. So it's working a little harder to separate them because it's a little more complicated, but it does. So eventually my error kind of goes down to 0. It's really nice. Here's one's a little bit more complicated. So when I try to run this against this image and try to segment it, then I actually have to work a little more, and it's not quite doing it. See? So it's not actually segmenting it well. So what I'm going to do, I'm going to add some hidden layers, you know, and see if I can get a little bit better results. So I added 2 hidden layers. I can add some more neurons if I need to, for example, and I'll run it. And you can see now that's actually trying a little harder to segment it. And it's still not doing a good job for me on my side. So I'm going to try to work with this a little bit more. Let's put another neuron here. Maybe I need 3 neurons. Okay, so it looks like it's trying harder to segment it. Okay, there you go. Look, see, see how it's trying to segment around? Trying to do that a little bit. You know, trying to divide those 2. Yeah, look at that. So you can see, so I might need to add another hidden layer. right, to get some more detail on this. So add another hidden layer. And I've actually done this. I've actually gotten it to separate. Look, it's really working on it. Look at that. It's taking a while to really crunch away. And what it's doing is just going around and around, repeating the data and weighting different things. You can see the different weights here, higher weight here, less weight here, a lot less weight here. See? Look at it's trying to segment those two. So you're actually watching. Let's add another hidden layer and let's add a few more neurons, Some more neurons here. Maybe I need more neurons. And so this is the thing that's, to me, that's most frustrating about neural nets, is it almost seems like it's a bit of a hocus pocus, right? You're just trying to play around with neurons, and people from experience realize for this particular problem, you need about this many layers and you need this many neurons. And it's kind of a little bit of a, black box magic going on here. And so you'll find that's the case when it comes to creating these neural nets. So there you go. It's crunching away. So this is really kind of a nice visual in 2 dimensions. But this data is actually multidimensional, and you can have data in thousands of dimensions. And when you're running tons of hidden layers and neurons to actually separate it and create this machine learning. This training is the most intensive part, as I mentioned. So you're actually spending a lot of time training here, and this is where you need your high-powered GPUs to help you do this. Now, what Amazon has done, and Azure has followed, is that they've created called automatic tuning. And so what happens is that the system goes in there and tries to automatically tune your layers and your number of neurons and give you the right parameters to more rapidly build the model that you need. Okay, and so it's really been coming along great. See, I put more layers in here. It's really actually trying to segment a little more. It will take a little longer, so we won't spend the whole time doing that. But are there any questions on this one before we proceed?
Yes, I have a question.
Yeah, go ahead.
I have, I guess, 2-part question. First, on the output where
Yeah.
it says test loss, are you trying to get that number as low as or closer to 0 as possible?
I am.
Okay.
I'm trying to bring these numbers down. Yeah.
Okay. And what is the determining factor for adding or subtracting hidden layers and neurons?
Once again, it's like a heuristic. Really, I'll be honest with you. But I'll give you a good example. Think of it in terms of position versus velocity versus acceleration. Okay, position is kind of like the first level, and then you might have a curve, might be the second level, and you might have a curve of the curve, might be the third level. Do you know what I'm saying? What the hidden layers do, they actually give you more control as you add more on the finer details. Okay, so if you have a straight line, then you only need 1 layer. If you have a circle, you may get away with 2 layers. But if you have a complex curve, you're going to need 4 or 5 layers to represent it, depending on how it's changing. So what adding more layers does, it actually deals with the differentials, the finer changes on something. Does that make sense?
Yes, and it also makes sense when you use the analogy video games.
Yeah.
It makes the order or complexity of a video game make more sense as well.
Yeah. You can see right now it's working its best to actually get around that curve there. So you're seeing some of it curve around. So
okay.
Yeah, and so there's lots of ways that people have solved this problem, and as you get deeper into it, you're gonna be amazed. Yeah. Hey, it's actually, look at that. It's actually kind of following that pattern. All right, so I won't any other questions as we watch this kind of try to train.
I have a question. This is
Sure.
Jamie.
Hi, Jamie.
Is there something that has more of a mathematical representation that we can actually see? Like this is visual, but is there like the source code so
Right.
we can develop a better understanding of what is actually happening mathematically?
Yeah, that's a really good question. It's not going to be presented today. Sorry about that. But there's tons of like deep dive math, TensorFlow and tutorials out there. What we're trying to do today is help you with the conceptual stuff, because once you get the conceptual stuff, you can do the programming. But then the doing the math part of it takes you, there's a whole new level of it, and there's a whole lot of papers out there on it, you know, and there's a few courses out there in Udemy on it as well. That's a good question.
Okay.
Thanks for
Thank you.
asking though. Good question. All right, we will move on. Thank you guys. Great questions. All right. All right, with that said, we're off of that one. And I don't know what's happened to my slides. They've decided to stay small. So we're gonna, let me see if I can make these a little bigger. I don't know why, but let's see, they do not want to change size. So we're gonna stick with what we got. With that said, oh, now they want to get, it was that one slide, it was giving me trouble. Okay. So really the process here that's been demonstrated is that you're gonna get your data, all right? And you're gonna turn it into tensors. So you have to go from images or whatever into mathematics. Then you're gonna build or pick a pre-trained model if one's out there, because that will help you a lot. And you're gonna fit the model to the data, and then you're gonna evaluate the model, you're gonna improve the experimentation, then you're gonna save and reload the trained data. So there's this whole process when you come to these that you go through over and over again. With that said, I want to talk about something that's really cool out there on the horizon. And this was just a few years old. Something called generative adversarial neural network. They're GANs, and they've been used in gaming for years, where you have one opponent against another. So what they do is they create two different neural nets, and they have them in a sense compete against each other. And they use a discriminator, which gives you loss and discriminates loss and discriminator loss and generator loss. So basically what it's doing is it's a way to refine the neural net more rapidly to do something which I call is knowledge creation. So and we won't get into generative neural nets very much from that, but I want to give you an example of a neural net that is using generative neural nets. And I'm going to give you a link here real quick. 1 second. For this. Okay. And my first question when I bring this link up is going to be, put this in your browser. And this is using a generative neural net. Here's my first question. All right. Is this a real person?
Says they do not exist.
You're looking, yeah, I should somehow blank that out. Let's go to the next one. Is this a real person?
Looks real.
It looks real, doesn't it? It's not. So is this a real person?
Wow.
The answer is no. Is this a real person?
She's cute.
The answer is no. Is this a real person? What do you think? And the answer is no. Is this a real person? And so you can see, guys, what's going to happen with the next generation. I mean, this is just you using our processors today. What's going to happen when we have these supercomputers? You know, what takes you 30 years to do, you can do in an hour using a supercomputer. And these quantum computers. So I'm trying to say happens when we get these quantum computers. We're going to have a whole new level of interaction. And you're going to have these characters that are just like you, but they're talking like you, they're thinking like you, but they're not real. And you're already seeing this today where they're doing this with speech. I don't know if you've seen this stuff coming on the internet where they have Obama talking, but it's not his face and it's not him, but it sounds like him. It looks like him. We believe it's him. It's because this is all happening using neural nets. So the technology is really rapidly and it's this generative neural networks, that this new technology that just came out, that's been a couple of years ago, where people are able to do what I call knowledge creation. It's something that we never thought computers could do, right? We always say, well, computers can do all this, but they'll never be able to think like a human. They'll never be able to create art. They'll never be able to create music, but they're actually doing that right now. And they're getting better and better at it. And it's going to come to the point where they're better than us. And so that's why you saw Stephen Hawking sound the alarm. AI is the scariest thing he's ever seen. And he was an astrophysicist. So there you have it. All right, with that said, that's generative neural networks. And so what I want to do, the last thing, and we mentioned tidy, and there's a section here in these slides on basically doing cleanup and memory performance. You need to keep that in mind as you work on these neural nets, especially in the browser. And the last thing I want to do today is show you how to do something that is not shown in Jason Mayer's course, and that is how to run these models on your local machine. So you can go to basically glitch, and you can do TensorFlow all day long. But what might happen is you create a model, and you might want to download that to your local and run it on your local. So let me show you what happens to you when you try to do that. Okay, I'm gonna go to glitch, and I'm gonna try to do that real quick, and you'll see what terrible things will happen to me. Right. So I went to glitch. Oh, not Gmail. Sorry about that. Glitch. Okay. And I'll glitch, and I'm gonna go to my dashboard where I just created some code. All right, and then here's my dashboard, and I actually created some code to create these tensors. Okay. And I created all these tensors, and we've been through this exercise, and you saw that. But I actually want to download this now and bring it to my local. So I can come down here and I go to Tools, and in Tools you can export the model, so you can download that model. All right, so you download the model. And so once you download the model, it's kind of like a tar zip. Once you do that, you want to create a folder on your local machine, and you want to unzip it. Okay, and so I actually did that. So let me go ahead and go to where I put that. Sorry about that. Well, I thought I put it. Oh, here it is. So I'm actually going to go there right now. Give it a moment. Okay. So I'm going to step back one and show you the folder. So what I did, I created on mLively, that's my main folder here. I created a folder called AI test. An AI test, I put that download, and then I unzipped it and got a tar file. So I had to unzip it again, and I got an index HTML. Okay, and so when I run that index HTML, I get this, but you can see it's not running, it's awaiting the TF download. So just by clicking that, putting that folder, unzipping it, and putting on my local, it doesn't run. I need to be able to run this and get it working on my local. So what I need to do is I need to install Node.js. Okay, I need to create that folder, which I did, and then I would need to create a Node server. So when you create Node.js, I'm gonna go ahead and bring up my Git bash real quick, and let me go ahead and Control C this, okay, and clear this. Okay, cool. And you can see right here, the one thing I want to do is I want to do an npm. So I've installed Node. So if I do --v, you can see. Sorry about that. I have version 7.10, so I can look at what version I have. And I have Node installed too, --v, you can see I have Node installed. So you'll install Node, when you go to Node, you'll install it, and then you'll install the server. So when you go npm, that's the Node package installer, you npm install http-server-d, that -g installs it globally. I won't do it here, but this is basically what you want to do once you install Node. -g. Okay, so that will install the server. I've already done, so I won't do it here. The next thing you want to do is, after putting those files in your test folder, wherever that's going to be in your server, you actually want to navigate to that. So if I go pwd, that shows me where I am on my server. Let me just go back one. So I would be in mLively, for example. And then I want to navigate to the AI folder where I have the files I just unzipped. So I go cd AI, and I can do a tab there, test. And if I do an ls, you can see I have those files, JS, here's my script.js, here's my CSS, and here's my HTML. Now at that point, I need to run the Node server in that folder. So all I have to do to run the Node server is hit HTTP server, all right? And Node understands what that means. So I'm gonna run HTTP server, and now it's running a server on my local machine. And it's telling me if I go to 127.0.0:8080, that's where it'll run. So let's go and see that and see if I got this AI program running on my machine. So I'm going to go to a browser right here. And you can see, lo and behold, it's running. Okay, number of tensors created is 3,000. Now, my question is, what is it running on? Is it running on my CPU, or is it running on my GPU? And anybody have an idea how I might determine that?
Since you did everything locally, I would say CPU, but I don't know how.
Well, I would think that too, but it's TensorFlow. So TensorFlow should be running on my GPU, which means it needs to run on WebGL, right? So here's my TensorFlow right here, and I want to go to the console. And you see all this stuff is in the console, and if I scroll down, let's see, I should be able to type some command in here. Scroll up and see here. Yeah, here's where I can put a command in here. And so I want to go tf-get backend. I want to see what backend is actually running on, okay? Let me run this. And when I do that, it said, look at that. What does that say to you? What's that say? Can you see that?
WebGL.
WebGL, which means it's actually running on my GPU, my graphic processor, because WebGL is the actual graphics processor. If you go to WebGL, let me see if it's something will come up for me. You can see this is the WebGL. It means it's actually running in my on my Chrome browser. See that three-dimensional turning cube? That turn, guys, can you see the cube?
Yes.
That means in order to do that, it has to be running on my GPU. So it's running in WebGL. And so what does that say to me when I hit in the console that says my tensor is running in WebGL, it's running on my GPU. So that's how you determine what it's running on. All right, cool. With that said, that's all there is to running, all right, TensorFlow on your local. And he didn't go through that in the course, and I actually commented on it. You know, we're doing all this great code. How do I run it on my local? So for me, the hardware piece, though it wasn't much for that course, because I've built node servers before, but I wasn't sure how it would be used to run on your local. It's really easy to do, so that my piece was like, because I teach this, I taught this to my interns just last week, and so I say you on your local, and so it's a pretty cool trick because you're gonna want to. So I got to tell you guys, you are not going to want to develop AI models in the cloud. I just want to tell you that right now, or debug AI models in the cloud, because the cloud is super expensive when it comes to doing development work in AI. Just going to tell you that. I went to sleep one night, woke up and had a $150 bill the next day because I had turned some AI on that I was doing development on, and I wasn't even doing anything. I just turned it on. So it's better, to much as you can, to do that basic experimentation if you can on your local. All right, and sometimes people will do all their debugging on their local as well. You know, just as much as you can, because once you get into the cloud, AI can get really expensive. Okay, so this is a good skill to know. Any questions there? Does this look easy?
Not at all.
You know,
That's why I've been so quiet this time. And you're like, these guys are quiet. I'm like, man.
I told my interns that, and I thought, oh, this is so easy. And they looked at me like, oh my God. and you know, I had to say that, I looked at him and I said, you know, I've been doing this for years. And so it just kind of bleeds off me. But when I started, it was hard. And so I had to work really hard. So, but once you get, and I don't always have successful demos. I'm always happy when things go well. But I had my last users group, if you were in it, meeting, I tried to do too much, and so I ended up going way over, and my last demo failed because I had fat fingered something wrong. It was embarrassing. I thought, next time I do this, I'm gonna make sure I hit the time. So I'm right on the time limit here, you know, my hour and a half, and we've already seen everything we need to know. Let me see if there's anything else left. There's just a few more things we'll hit here. There's lots of data out there. So if you want to start experimenting with models and playing around and you need a data source, well, Kaggle.com has tons and tons of data. So you just go out there and it's all made for artificial intelligence, and they have lots of tutorials to help you get started. So that's just, you know, just fantastic. Here's videos and, you know, training is just, you know, just top-notch stuff. And then with that said, I mean, one of the things they like to do is, you know, home sales and learn about featurization and what's important. Another thing out there, we will be circling around and not doing the JS tensor again, but doing the Python tensor course certification sometime in the future, not too far away. But there's a whole course out there that you can hit. All the links are on the slides. And well, I mean, and there's a Udemy course that matches this, by the way, and it's all on. Let me see if I can bring this up. all free on the web. So the Udemy course, you have to pay about $10 if you wait for the deal. But this is a whole book on using TensorFlow with Python. And you can click here and there's slides you can download and tutorials you can work through. So it's like, wow. I mean, they're just throwing this stuff at you. And people who get into TensorFlow and get really good at it make like $200,000 a year. I mean, the pay scale is really nice. And so, and also the last thing I want to guys hit before I leave here is Google Colab. If you're doing TensorFlow and Python, Colab is all set up for you. So if you have a Google account, you can just go to Colab and just start, working with TensorFlow right away. It's all set, programmed, ready to go. So the nice thing about Glitch, it does is just JavaScript, but Google Colab is specifically, set for Python programmers. So I think some people mentioned they had some Python experience. And so if you have a browser, all you have to do to get to Google Colab, and I'll just bring up one of my browsers here. And having browser wars today. And I'm in the browser right now, so I can just go, oh, Colab. And so if you got a, like you said, if you have a Google account, you go to a Gmail, for example, go to Colab. I mean, you can go to Colab right away and just start working Colab. And what Colab is, and we'll learn more about it, is pretty much JavaScript on steroids is what it is. And so you can go in there and start programming. I think I had a little lab here, Python course we have built, and you can do Python all day long in Google Colab. I had an untitled one here. I'm not sure we had here. But it's just, here it's just you have these little screens and you can start programming right away. And so it's really nice. And I'll give you one more example before I leave, or I'm going to hang on for a while, but I will end right on time today. Here's an example. Let's do just a real simple TensorFlow here. We'll go ahead and what is a TensorFlow version, for example? We'll add some code here. So I just added that, and then I'm going to go, okay, let's import TensorFlow. And as TF. And then let's go ahead and print the version. TF _ version _ did it right. If not, it'll tell me I did it wrong. It'll tell you that. And I just run it. And hopefully I didn't fat finger anything. And everything's running really slow today for some reason. And it's 2.8 version of TensorFlow. And then you can go on and you can see stuff here where I programmed a vector, and I programmed a matrix, and I just went on with it. So here you can just start doing TensorFlow all day long. So it's just really sweet. It's all there in the browser, ready for you to use. So that I don't think artificial intelligence has been made more easy. It's probably more information on it and getting started with it than anything I've ever seen in any technology right now. Yeah, so that is the presentation. What do you guys think?
Amazing, because it seems almost as if you're able to pick a person out of a crowd and have them do brain surgery.
Absolutely. Absolutely. You can pick anyone out of the crowd. Absolutely. It's really, it's amazing stuff. It really is. And they've made it really easy to use. So they have stuff like, they've really tried to make it human understandable. They have a programming language called Keras, which sits on top of TensorFlow that makes it even easier to program and understand. You'll spend most of your time doing data cleaning. About 80% of your time you spend doing data cleaning, and then about the other 20% working with models. That's where you get all these data analytics jobs opening up. Yeah. All right, that was the presentation, guys. I am going to hang out if there's any questions. Okay.